In this video, I'm going to talk through a few geometry questions that involve surds. So first of all, before we start the questions, I just want to remind you of a couple of formulae that hopefully you're already familiar with. First of all, if you want to find the area of a triangle, you're going to do base times height and half it. And you need to make sure that your base and your height are perpendiculars. And then for the area of a trapezium, you're going to do the two parallels added together, A plus B, half it, and then times by the height, which is the perpendicular distance between A and B. Okay, so we're going to need to use those formulae as well as a few other geometric facts in order to be able to answer these questions. So first of all, I'm just going to go through these two. We've been given a shape and we've been given the length, but in these cases, the lengths have got surds involved in them. So all I want you to do for these is first of all, find the area of the shape and then also find the perimeter as well. So we've got a square here, and then afterwards we have a right angle triangle, and this length here, in case you can't see it, is 5 minus root 2. Okay. Okay, so I'm going to talk through the answers. So first of all, I'm going to work through the square. Because this is going to be a little bit more complicated, I'm going to do my working out on the board and then I'm going to transfer my answer to this afterwards. So to find the area of the square, I need to do base times height. And because we know that it's a square, we know that the base and the height are equal to each other. So I need to do 4 plus root 3 times 4 plus root 3. And it's the entire base times the entire height. So to show that, I need to put brackets in to show that they're being multiplied. And now the question is a simple matter of expanding and simplifying that double bracket with surds in. So 4 times 4 is 16. 4 times root 3 is 4 root 3. Root 3 times 4 is 4 root 3. And root 3 times root 3 is root 9, or 3. I can now simplify what I've got. My integer parts, I've got the 16 and the 3, which comes out as 19. And I've got 4 root 3 plus another 4 root 3, which is 8 root 3. I haven't been given any units in my answer in the length on the question, but you might do have in the exam. So if they gave you any units in the question, make sure you put your units in the answer. So the area for this, 19 plus 8 root 3. For the perimeter, I'm just going to be adding this to itself 4 times. You can either write 4 plus root 3 plus 4 plus root 3 plus 4 plus root 3 plus 4 plus root 3, or you can just multiply it by 4 because you know all 4 of them are the same. So for the perimeter, I'm doing 4 lots of 4 plus root 3, put it in a bracket to show it's 4 lots of the whole thing, and that comes out as 16 plus 4 root 3. Again, I would be looking out for units if I had this in an exam in case I needed to put them on as well. But that is my perimeter. So I've got the area and the perimeter for my square. I'm now going to go through the area and the perimeter for the right angle triangle. So for this, we're using base times height divided by 2 as a process. So first of all, for the area of the right angle triangle, I'm going to be doing 5 plus root 2 times 5 minus root 2 all over 2. Now, you can expand and simplify the top just step by step, that's absolutely fine. But some of you might have noticed that this is the complement of this. They're exactly the same except for a plus and a minus. So I can actually use difference of 2 squared to make my life a little bit easier. The first bit squared is 25. The second bit squared is 2. And it's all divided by 2. Okay, if you did expand it out and simplify step by step, you would still get to the same thing on the top, so that's absolutely fine. But we get 23 over 2. So that has an area of 23 over 2, or 11.5. Okay. Okay, and again, I've not been given units, so I'm leaving my, my units blank on the answer. Now, for the perimeter, I need to add all of the lengths together, and I haven't been given this length here. So the first thing I'm going to have to do is work out what that length is. Now, because we've got a right angle triangle, hopefully some of you are thinking Pythagoras would be helpful, and you're right. If you were thinking that, I need to do this squared plus this squared equals to this squared. I'm going to take this away because it's going to take a little bit of time to do this. Okay, so first of all, I'm going to call this length here C, just so I've got a symbol to represent what I'm looking at. So C squared is going to be 5 plus root 2 squared plus 5 minus root 2 squared. And I'm just going to go through the process, remembering that at the end I need to do some square rooting as well. So 5 plus root 2 squared is 5 plus root 2 times 5 plus root 2. That's going to come out as 25 plus 5 root 2 plus 5 root 2 plus 2. And then the second bit, sorry, I'm just going to have to put it on a second line so I can fit it all on. This one squared is going to be 25 minus 5 root 2 minus 5 root 2. And then minus root 2 times minus root 2 is plus 2. So I've got to add all of these together. Now, looking at the 5 root 2 bits, a couple of them are positive and a couple of them are negative, so they're going to cancel out. So I'm going to end up with 27 plus another 27, which comes out as 54. So C squared is 54. And to work out C, I'm going to have to square root. Now, I'm working with surds. I'm doing this without a calculator, but I'm thinking, are there any square number factors of 54? And there are. Okay, I can have root 9 times root 6, which is 3 root 6. So my hypotenuse here is 3 root 6. So for perimeter now, I need to add all of those lengths together. So I'm going to do 5 plus root 2 plus 5 minus root 2 plus 3 root 6. And then I need to simplify. The minus root 2 and the plus root 2 cancel out, and I'm left with 10 plus 3 root 6. Oops, sorry. 10 plus 3 root 6. And that is my final answer. But that Pythagoras in the middle there made it a much longer, more difficult process than we had for the perimeter of the first one. Okay, right. Oops, sorry. I'm now going to have a look at a couple of more difficult questions using surds and geometry. So for this one here, we've been told the area, we've been told one of the lengths which has a surd in, and we've been asked to find out what the height is. And for this one here, we've got a trapezium. Apologies that I've just had to draw these shapes and they're not perfectly drawn. We've got the two parallel sides here, and we've got the height between them, and we need to find an expression for area. This one's a bit more complicated than the ones we've already seen, just because you have to use this formula. Okay, so if you can't see it, this length here says 2 plus root 3. This length here says 8 plus root 6. This length here says root 6, and this says root 3. So pause the video, have a go at those questions, and then I will go through them in just a moment. Okay, so I'm going to pop the board over here so you can still see the questions as I'm going through it. So for the first one, I'm going to write an equation about the three things I've been told. I've got my height and my base and my area. So I can say that if I did 2 plus root 3 times by my height, I would get the answer of 8. Okay, and I now need to solve this for x. Now you could try and expand it and solve that way, but then you're going to have x appearing twice. So the easiest way to do this is divide both sides by the bracket to get x on its own. So I've got x equals 8 over 2 plus root 3. Now hopefully you'll be in the habit of whenever you see a surd on the bottom of a fraction, you feel a desire to rationalise the denominator, because that's how we're going to have it later on. It's going to be much simpler. So once you've got a fraction like this with a surd on the bottom, we're going to rationalise the denominator. The way I'm going to do that is I'm going to times by the complement of 2 plus root 3. So I'm timesing by 2 minus root 3. And then I just need to expand and simplify those brackets. So on the top, I'm going to get 16 minus 8 root 3. On the bottom, you can expand and simplify step by step, or if you're confident with it, 2 squared is 4, root 3 squared is 3, so 4 minus 3, which is 1. 16 minus 8 root 3 over 1 is just 16 minus 8 root 3, so that's our answer for the area of this one. Sorry, not the area, x. And if you wanted to double check your answer at the end, which you probably would in an exam situation, you could do this times this and make sure that you come out with 8. So 16 minus 8 root 3 times 2 plus root 3. 16 times 2 is going to be 32. 16 root 3s minus 16 root 3s, and then minus 8 root 3 times root 3, or minus 8 times 3 is going to be minus 24. So we've got 32 minus the 24, which gets us the 16. And we need a minus 8 root 3 there, sorry, hold on. So yeah, that's going to come out, that's going to come out as 8, which is what we wanted because the area is 8, okay? Right, moving on to the trapezium now. I need to add the 2 parallel sides and then half it before timesing by the height, which is root 3. So I'm just going to write all of that in one big sum first of all, and then I'm going to start working it through. So the area is going to be 8 plus root 6 plus root 6, all of that halved, and then times by root 3. So on the top here, I'm going to have 8 plus 2 root 6s that I need to half, and then times by root 3. So 8 plus 2 root 6, if I had half of that, I would have 4 plus 1 root 6. And I need to times that by root 3. I'm putting my brackets in. You can put them in from the very beginning if you want to, just to make sure you don't miss them. Okay, so I'm doing root 3 times 4 plus root 6. Root 3 times 4 is 4 root 3. Root 3 times root 6 is root 18. You can just times them together. Now, root 18 can be simplified to root 9 times root 2, or 3 root 2. So my answer for this one is going to be 4 root 3 plus 3 root 2. Always make sure you simplify as far as you can with these questions. Okay.